So what is probability all about? What does it mean? So a fancy way of saying it is the measure of the likelihood of an event occurring, but that sounds a little bit like, a little bit sort of advanced. The way I think of it is you have something that is uncertain, some event, and you try and give that uncertain event, you give it a number. And that number tells you how likely it is to occur. So basically, what probability is trying to study is it's trying to study how to give numbers to tell you how likely something is to happen, and it's using the system of numbers to do that. That's my simple definition. Does that sound? Give me a thumbs up if that makes sense. Give me a thumbs down if I've lost you. So you have some uncertainty. You're going to try to give it a number, and that number is telling you how likely is this thing to occur. Now, that's very wordy, so what we need now is some symbols. So we often use the probability, the letter P, and the event that we're interested in, we put inside the brackets, and then we use a formula, and we say, look, how many possible outcomes, so number of possible outcomes, and then on the top, we have number of favorable outcomes. So and the favorable is in terms of the event that we're discussing. So a very famous example in probability is throwing a dice. And so if I have to use this idea that I've said so far, there's this uncertain event, it's throwing a dice, and what we're interested in is throwing a 6. Now, if we want to give that probability a number, a likelihood of occurring, well, how many possible outcomes are there if we throw the dice? Well, there's 6 different outcomes. How many of them are favorable for throwing a 6? Only 1 out of 6 are favorable. And so the probability of throwing a 6 is 1 out of 6 on a dice. Now, we can also write this in terms of decimal numbers. So 0.166, I think, is what you would have on your calculator, or we can write it in terms of percentage. And so this number can be written in 3 different ways. Give me a thumbs up if that's sounding familiar from previous classes that you've done on probability and you feel comfortable with those ideas. Welcome to Selakani, Atlechang, Onalena, who have joined us. And we're just sort of getting warmed up for the new topic of probability. So let us have a look at what's called the probability scale. So like I said, probability is about giving a number to an uncertain event. And this scale goes from 0 to 1. Now, if something has an even chance, or it's equally likely to happen or not happen, we say it has an even chance, or we say it has a 50-50 chance, or a 50% chance. If we wrote this as a decimal, it would be 0.5. As a fraction, it would be 1/2. If it is more likely to happen than not, so we go to the right, what's a 4 in 5 chance? Well, that would be an 8 out of 10 chance, or a 0.8, or an 80% chance. And that's pretty likely, like it's most likely going to happen. If I get to here, it's certain, it's definitely going to happen. And that's 100% or 1. If I go to the left, let's say a 1 in 6 chance, this is not very likely. If you throw a dice, you might get a 6 sometimes, but it's not super likely. And so we can write that down in the unlikely part of the probability line. And then if we get down to 0, it's impossible. It can't happen. And so probability will always be a number between 0 and 1, or a number between 0 and 100%, or as a fraction, as a decimal, also between 0 and 1. Okay, so that's the basics. Let's see this in action. So that's the main formula that I described at the beginning. Let's try and answer this question. What is the probability of getting a score which is a factor of 6? And you're throwing a dice. See if you can tell me what your answer to that is. Read the question carefully. What does it mean for a factor of 6? So if you imagine, what are all the possible outcomes? These are all the possible. How many of them are a factor of 6? What does it mean for something to be a factor? It means that it divides 6 exactly. So I think 1 divides 6, 2 divides 6, 3 divides 6, 6 divides 6. So the probability of getting a factor of 6, well, there's 6 possible outcomes, but 4 of them are favorable in terms of the event question. Now, I don't see a 4 out of 6, but maybe that can help you figure out which option that goes with. So 4 out of 6 is the same as 2 out of 3, and Atlakang is quite correct. It's going to be a C. Okay, let me rearrange this question. What is the probability of getting a prime number? Which of the 4 options would be correct for the probability of throwing a prime number when you throw a dice? It's still going to be out of 6, but how many prime numbers are there? There's 2, 3, and 5. So there's a 3 out of 6, which is the same as a half. And the correct answer would be B. Another way of saying that is a 50% chance. Another way of saying that is 0.5 chance. Okay, so it seems like the basics of probability are coming back to you, which is awesome. Some basic words that come up in probability would be the outcome. An outcome is a single observation of an experiment. So if you think of the experiment as throwing a 6-sided dice, and a single observation, an outcome would be like throwing a 1, throwing a 2, throwing a 5, and so on. A sample space is just the collection of all possible outcomes. So often when I look at the sample space, I use the letter S, and then I use the squiggly brackets, and then I list all the outcomes of the sample space. It's not the only way of doing it, but it's one of them. What is an event? An event is a set of outcomes of an experiment. So the way of thinking about that is, what is the event of throwing a prime number from the sample space? Well, the prime numbers were 2, 3, and 5. So if I threw a 2, a 3, and a 5, I had the event of getting a prime number. And so these are outcomes that are all inside the event throwing a prime number. Probability is just a scale between 0 and 1. It tells you how likely something is to occur. We've discussed that already. And then what's relative frequency? So really all relative frequency is if you do something that is uncertain in the real world. So let's say you throw a dice. No, let's say a coin. Let's say you throw a coin 3 times. Oh, I just want to let someone in. Someone is. Yeah. So let's say I throw a coin 3 times. What are the possibilities for that coin? Well, I could get heads and tails. But because, let's say in the real world, I get 2 heads and 1 tails. Then I say to you, what is the relative frequency of throwing heads? Now, I know a lot of you will say it's 50% normally, but you've just done something in the real world. And you had 3 possible trials. And how many times did heads come up? It came up twice. So the relative frequency of heads based on your experiment is 2 out of 3. And the relative frequency of tails would just be 1 out of 3. So sometimes relative frequency is called experimental probability. So it's kind of like what happens when you actually do it. And it's important that you know what that word means, but we don't need to obsess about it. Give me a thumbs up if you followed what relative frequency is. Give me a thumbs down if I should do more stuff. It's just basically like if you count in the real world and you work out how often something came up, that's the relative frequency. And sometimes we use the word experimental probability to mean the same as relative frequency. Now, some other things that are going to come up in this section. We need tools that help us visualize how many different outcomes there are for events. So I'm going to give you all sorts of exciting events like cards, like choosing a card from a pack of cards, or flipping coins. And we need clever ways of visualizing them. So some of the tools you will learn about are tree diagrams. You will learn about Venn diagrams. And you will also learn about contingency tables. And you will notice on the lesson plan for this topic that these three are there: tree diagrams, Venn diagrams, contingency tables. You will see some examples of tree diagrams later today. All right, let's do another multiple choice question. I want you to do this all by yourself. There's a toothpick made up of 5 triangles with numbers on it. Read through the question and tell me which one you think is true. Okay, the answers are coming through. Now, there are 5 possible outcomes. What is the probability it lands on an odd? So what's a favorable outcome? Well, 1 is odd, 3 is odd, 5 is odd. So there's a 3 in 5 chance I end up with a favorable outcome, which is an odd number. And so for me, the correct answer would be D. Fantastic. Love it. Oh, welcome to Amelia, who has joined us, and also to Siamtanda, who has joined us. Here is a special dice. It is an 8-sided die. And the question is, if this dice is thrown once, what is the probability that the face lands with a prime number facing upwards? Which of the 4 options do you think has a prime number? What is the probability of a prime number landing face upwards? Okay, well, let's have a look. There are 8 possible outcomes. Let me even draw a little. So these are all the possible outcomes. How many of those are prime numbers? 2, 3, 5, 7. So of the 8, 4 out of the 8 are prime. So the probability of getting, oh, flip, my thing just changed. Hold on. Let me just, what happened there? Oh, let's see if I can get it. Oh, I got it back. There we go. So 4 out of 8, but now there's no 4 out of 8, so that's the same as a half. And so it would be C. Everyone okay with that? Give me a thumbs up if you guys are you with me? Are you with me? Okay, fantastic. So we are getting more familiar with this probability thing. So let's just keep swimming. All right, here is a different type of question. It's dealing with the word Mississippi. So it says, each of the letters of the word Mississippi are written on separate pieces of paper and are then folded, put in a hat, and mixed thoroughly. So what we have is like, here's the hat, and one of them has an M, and one of them has an I, and then there's one with an S, and another one with an S. You see where this is going. So if you pull one of those pieces of paper out without looking, what is the probability that it lands on an I? Or you pull out one with the letter I. Which of those 4 options would be correct? Which one do we think it is? Welcome to Intercanny, who joined us. Nicole joined us. Yeah, welcome, everyone. It is good for you to be with us. So let's have a look. How many possible options? We have 11 possible options. How many of them have an I? 1, 2, 3, 4. So there is a 4 in 11 chance of getting an I. So the answer is A. And if I look at the chat, A's are coming through. Fantastic. All right, I'm going to change the question now. What is the probability of drawing a card with the letter P on it? What is the probability of drawing a card with the letter P on it? Now, there's no option here. I think that's correct. You might have to just give me a number in the chat. Onalena, Silikane, Kani, Siamtanda, Atlechang, the answers are flooding in, which is fantastic. So I get 2 out of 11. And so does everyone in the chat. So we are winning at life. Let us continue our journey into the probability land. So the next type of situation that they love to talk about in probability are playing cards. Just to make sure that you know how playing cards work, there are 4 suites with playing cards. There are 2 red and 2 black. We have, under the reds, we have the hearts, and we have the diamonds. And under black, we have the spades, and we have, what is the other one? Clubs. Just in case you're unfamiliar. And then for playing cards, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. But we also have an ace at the beginning. So there are 13 types of cards, and there are 4 suites. So that's where they get the 52 playing cards. Okay, here is the question. There are 4 queens and 4 kings in a deck of playing cards. That makes sense because there's one for each suite. What is the probability that a card chosen is a queen or a king? And you have to choose from A, B, C, or D below. What do you think the correct answer is going to be? I know there are 52 possibilities for what I'm going to draw, but how many of them are favorable in terms of my event question of a queen or a king? So probability queen or a king. Which option do we think it is? Well, there are 4 queens and 4 kings. And if I get a queen or a king, I'm a happy camper. So I think the answer should be 8 out of 52. But there's no 8 out of 52 here. Is there anything equivalent to 8 out of 52? Well, I see lots of answers of B coming through. And the reason is that 8 out of 52, and we can use our calculator, is the same as 2 out of 13. And so my correct answer would be B. I want to remix this question. I want to ask you, what is the probability of getting a jack when drawing from a collection of cards? What is the probability of getting a jack? And you can choose, the correct answer is here. Oh, is it here? Let's have a look. Yes, it is. From A, B, C, or D. What's the probability of getting a jack from your playing cards? So there are 52 still as a choice, but this time a favorable outcome is not a king or queen, it's just a jack. How many jacks are there? There are 4, and that is equivalent to 1 out of 13. So the answer is A. All right. What is, okay, yeah, that's fine. We've got that. Okay, now before the break, we're about to have a break. We might need to bring in some new tools for the job here, but just read this question. And I want you to tell me, I'd love to hear someone's voice if they're willing to. What makes this question a bit more interesting than the last ones? So it says a fair coin is tossed 3 times. So we toss it 3 times. What is the probability of obtaining 1 heads and 2 tails? A fair coin is one that is not loaded, so there's an equal chance of landing heads up or tails up. So that's just saying it's a 50% chance either way. Why is this question a bit more difficult? Who feels like they can give me some sort of guidance around why this question is a bit more difficult? Or just a comment. What do you think, Atlejan or Kelebogile? What makes this question a little bit more exciting? When I say exciting in inverted commas. I think it's because the event does not occur once, but 3 times. Atlejan, I could not have said it better myself. It's the fact that it happens 3 times, which makes it more difficult to know what's going on. I also think the fact that they want to know when it's 1 head and 2 tails is also a bit more tricky. So I'm going to give you a awesome way of keeping track of when questions get difficult like this. And this is called a tree diagram. So if I throw my coin the first time, there are only two options, heads and tails. That is not difficult. But if I throw it a second time, it now gets a little bit more difficult. But what's lovely about the tree diagram is I just say, look, for the second time I throw it, I just have the same choices, heads and tails. And I can just say here, that was my first throw. And here was my second throw. Now what I've got is I've got a diagram that says, look, one option is heads, heads. One option is heads, tails. One option is tail, heads. One option is tails, tails. And that's all the possible outcomes. Now, the problem I have is that my question said it was for 3 times. What do you think I should do to help me handle tossing it 3 times? What do we think I should do? If I follow this tree diagram is helping me keep track of things. What should I do to try and include 3 times? Or 3 tosses? I think I should just extend my tree. Give me a thumbs up if you were thinking in your head, add another layer on the tree. Okay, so let's think about this. Heads, tails, heads, tails, heads, tails, heads, tails. Now, life got exciting quickly there, but at least I can see heads, 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 tails. So you know what? I'm going to start counting how many possible outcomes are there. 1, 2, 3, 4, 5, 6, 7, 8. Well, thank you, tree diagram, because remember, I want to know what the probability of getting 1 heads and 2 tails is. And the tree diagram has just shown me that there are 8 possible outcomes. Now, I want you to look on my tree. How many of them have the situation 1 head and 2 tails? If I look at my tree, how many of the journeys, there's 8 possible journeys, how many have 1 heads and 2 tails? And can you spot them? Let's go hunting. 3 heads, not very helpful. 2 heads, 1 tail, not helpful. Heads, tails, heads, not helpful. Oh, heads, tails, tails. Number 4 is my first favorable outcome. Is there anything else? Tails, heads, heads, no go. Tails, head, tails. Oh, that's not bad. Tails, heads, tails. So number 6 is a good one. What about tails, tails, heads? That's number 7. So what about tails, tails, tails? No, I need 1 heads and 2 tails. So what do we think is going to go in this block here to be the number of favorable outcomes? And which option in the chat is the correct, in the box is the correct answer? So I want to know what goes here, and then I want to know what of the 4 is the correct answer. The options that would work would be heads, tails, 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 heads, tails, and tails, tails, heads. There are 3 of them. You don't need to go that fancy. You just need to know it's 3 out of 8, and it's that. Now, that was quite a bit harder, but I've at least now introduced you to this marvelous thing called the tree diagram. And boy, is it your friend when they start having multiple outcomes. Give me a thumbs up or a happy face if you could mostly follow that example. Thanks, Atlechang. Selekani, I see that hand. Kelebohile, I see it. Keep those thumbs coming so I can get a feel for the class. Simtanda, fantastic. All right. Okay, everyone. Thank you, Intakeni. Thank you, Nokabonga. I see those thumbs. All right. Let us stand up. We have done half an hour of solid maths, and that's no joke. So let us stand up and just take a little quick break. We're going to do 3 deep breaths. Breathe in. Breathe out. Breathe in. Out. One more nice deep breath. Breathe in. Okay, let's give it a quick shake. Shake out those arms. Get the blood flow moving. Shake out the legs. And let us do 15 jumping jacks to get the heart rate pumping. Okay, 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My heart is full of blood that is pumping. I want you to, thank you, Amelia. Thank you. I'm glad that I can still do 15 jumping jacks. Give me an emoticon to describe how you are feeling. Maybe you can give me the muscle emoji. I don't know, is the muscle emoji there somewhere? Maybe you can find it in the chat. I think we need more emojis. I need to go and find how we can get more emojis in the chat. I think that would be awesome. Okay, everyone, let's go. Let's go and do part 2. So here is another question where it's a little bit tricky, but not terrible. What tool do you think I'm going to use to help me do this question? What tool would you use to help you do this question? I would use a tree diagram. Yep. Silicani, absolutely, because you're throwing 2 things. You've got this dice and you've got a fair coin, and now they're thrown together. So how am I meant to keep track of what's going on? I think I would just do heads and tails for the first branch. See if you can think about what the second branch would be, and then see if you can use the tree to help you answer the question. I'll give you guys some time to think about that. So first branch is that. Now heads and tails. I suppose I could have done it the other way around, but it doesn't really matter. It's not the neatest tree in the world, but I'm just trying to visualize what are the possible outcomes. And heads 1, heads 2. Now, if I look at the question, it says, what is the probability of getting a multiple of 3, or heads and a multiple of 3? So I have to be in this part of the tree. I also need to ask myself, how many, maybe we can help each other. How many possible outcomes are there for this uncertain event? How many in total? How many possibilities are there for this? If I throw a dice and a coin, how many different ways can that happen? Well, there's 6 for heads and there's 6 for tails. So I think there are 12 things that can happen. But now, of those 12, I'm only interested in the ones that are multiples of 3 and land on heads. So how many of those options land on heads and are multiples of 3? See if you can see the pathway through the tree. Okay. Well, let's have a look. So if I get heads, I'm here. Now a multiple of 3 would be 3, or it would be 6. So of those options, I think there are only 2 that are heads and a multiple of 3. Because what are the multiples of 3? There's 3, 6, 9, 12, 15, 18. So the only ones that I can see in that collection are 3 and 6. So we have 2 out of 12. But now there's no 2 out of 12 here. So what option should be the correct one? Well, 2 out of 12 is the same as 1 out of 6. Yes, that's it. So a tree diagram is a really useful tool for taking events that are compound events. We say compound because there's like little pieces to the event. It's throwing a coin and it's throwing a dice. And when we have the situation, often a tree diagram is helpful to keep track of all the different possibilities. Otherwise, you just get a bit overwhelmed by all the choices. Give me a thumbs up if you followed that question. Or let's actually do the scale out of 10. How well did you understand this? 0, no understanding. 5, some understanding but needs improving. 10, you've got this. You're like, I've got this. Where would you be on the scale of 1 to 10? All right. Thank you, everyone, for voting. I see the votes coming through. I love my class participation. Yeah. No, Amelia, don't worry, because this question was tough. Because you guys have signed up for the S class, I have tried to make things a little bit more sneaky, tricky. We'll come back to that one. Let's have a look here. Don't want this. No, we'll do compliments the next time. Not that one. I want to do, okay, let's do this one. 2 fair dice are thrown. What is the probability that the 2 scores do not add to 7? Now, I don't think that the best way to do this is a tree diagram. And here's why. If you have a tree diagram, look at what's going to happen. You get 1, 2, 3, 4, 5, 6. So that is for when you throw the dice the first time. What is going to happen if I put 6 branches on that one and keep going? What is my big problem going to be if I use a tree diagram in this question? So sometimes using a tree diagram is a good idea, but sometimes it's better to use other tools. And I think the real problem I have here is that it's going to get too complicated too quickly. Like if I have 6 options here and 6 options there, I'm going to have 36 options, and my tree is going to take me half the exam to draw. So instead of using a tree diagram, we are going to use a table. And if I have a table and I'm throwing 2 different dice, on the top, I'm going to have 1, 2, 3, 4, 5, 6. Now, that is the first part of my table, and that is dice number 1. What do you think I'm going to do to represent dice number 2? So if I say this is dice number 1, what am I going to do to represent dice number 2? What would you do if you were thinking logically? I think I would go along and say, look, if that's dice number 1, dice number 2 could just go down here. And to make this a table, I'm just going to draw lines across like this. Now, it's not the best table in the world, but for the context of today, it will do the job. Now, we have to now begin to answer the question. What is the question about? It is about the sum. What is the probability that the scores do not add to 7? So it's about adding the numbers together. Can anybody suggest, oh, there we go, Atlechan got it, perfect for the second one. How could I visualize the sum of the two dices? I've got my table, I've got dice number 1 on the top, I've got dice number 2 on the side. How could I visualize the sum of the two dices? You can put your hand up and tell me audibly if it's quicker, or maybe somebody can tell me, how am I going to, I need to understand what are the different options when I add two dice together. Just put it in the chat what you think you would do. If you were trying to, the goal is to visualize this question. I'm not going to answer it yet. I'm just trying to get a feel for what's going on. How could I understand the sum of two dices, the different possibilities? I think a lot of you are thinking this in your head. What if I add 1 and 1 together, I get 2. And if I add 1 from dice 1 and 2 from dice 2, I get 3. And then I get, if I have 1 in dice 1 and 3 in dice 2, I get 4. And oh my goodness, there seems to be a pattern developing. Give me a thumbs up if you see the pattern. Now, I've given you some help. I want you to try and work out what is the probability that the two scores do not add to 7. I want you to take this table and I want you to use it to help you figure out which answer you think is correct. Which answer do you think is the correct one? I think we all know where this table is going. How clever is it that we can represent these two dice like this? This is where maths is so good. It's such a clever way of taking something complicated and making it simple. So 3 plus 6 is 9. Even this pot feels 4 and 1 is 5. Yeah, 6, 7, 10, 6, 7, 8, 10, 11, 7, 8, 9, 10, 11, 12. So my table that represents the sum of two dice is this. I still need to work out my probability. And I want you guys and girls to commit. So what's the probability? Do not add to 7. How many different sums? Well, I would say that there's probably 36 because there's 6 times 6. How many of those do not add up to 7? How many of those do not add up to 7? Well, I can see that these are the ones that add up to 7. And there's 6 of them. All the other ones do not add up to 7. And so we would say that there's a 30 out of 36 chance of the sum not adding up to 7. But there's no option that's 30 out of 36. So which one would you choose? This is the same as 5 out of 6, which is this one here. Okay, now That was also a little bit tricky, but I want to show you how nice is this table diagram for describing this situation. So in our toolkit, not only do we have tree diagrams, we also need tables to help us visualize outcomes. And knowing how to set this out is really most of the difficulty in doing this. Now, I don't expect you to be perfect, but give me a score out of 10 for how well you feel like you understood that example. Out of 10, where would you put yourself? For the way I visualized the sum of the two dices. Yeah. Thanks, Amelia. Thanks, Simtanda. I see those scores. Let's see. Okay, let's do some more multiple choice questions around tree diagrams. So here is my tree diagram question. It says here, two fair six-sided dice are rolled and their scores are added together. The sample space on the right can be used to show the different possible outcomes. What should replace the star? What should replace the star in the tree diagram? Well, we know that the way we did it last time was just to add the two values together. So this should be a 7. And so the answer will be B. I think that's quite easy after the last example we did. Okay, let's have a look at this. Now, this is just some notation about something called the complementary set. So if we have the probability of some event A occurring, the probability of will always be, okay, let's put it this way. If I say the probability of A and the probability of A dash will always add to 1, this is called the complementary set to the event A. So if I rearrange this, we could say the probability of A is equal to 1 minus the probability of, or actually, let's do it this way. I'll talk more about this in future lessons, but it's just 1 minus the probability of A. Using what's on the board here, can you work out the probability of A dash? A dash is called the complement of A, but I need to do some more stuff around set theory before I get into that. We'll talk more about this in the next lesson. But today I'm just introducing you to the notation. So if you know that the probability of A is 3/4, what is the probability of the complementary event occurring? So we just have 1 minus 3/4, which is 1/4. And so the answer is D. So that's some more probability language. We get D. Here's some more stuff like that. If the probability that my train will be late tomorrow is 1 out of 10, what is the probability that I will not be late? So we'll say the probability of being late, the train being late would be 1 over 10. What is the probability of the train not being late? This is how we would write it in probability notation. We can also say that you'll either be late or you won't be late. So we know that those two together give you 1. How are we going to work out the probability of not being late? This little dash also sometimes means not. So the probability of not being late is just going to be 1 minus 1 over 10, which is 9 over 10. Okay, so these are just called complementary events, and that's just some language that we have. Do we have one more question here that I can? Okay, let's just use that word not. Let me just move this down, Control X. Let's move this down here. Let's say the last question of the day. A fair dice is thrown. What is the probability that the score is not a factor of 6? What is the probability that the score is not a factor of 6? So we'll say not a factor of 6. And you're just throwing a normal dice. So there's still going to be 6 outcomes. I want to know how many are not a factor of 6. Is 1 a factor of 6? Yes. Is 2 a factor of 6? Yes. Is 3 a factor of 6? Yes. Is 4 a factor of 6? No. Is 5 a factor of 6? No. So how many are not a factor of 6? Well, there's 2 out of 6, which is the same as saying 1 out of 3. And so the answer would be B. Now, what's difficult about that is the word not. And so some people would say is, why don't you work out the probability of something being a factor of 6 and then subtract it? So what you could have done is you could have said, look, the chance of getting a factor of 6 is 4 out of 6. And then all you need to do is say 1 minus that to get your answer. And so it would give you the same answer, which is 1 out of 3. But it just depends on how you see the question. Okay, everyone, I think I did quite a lot with you today. So